and welcome to our webinar, 5 Quick Wins to Optimize Your Databricks Environment. My name is Susie. I'm your host, Head of Marketing at Blueprint. And if you don't know us, we are a data intelligence company that's been a Databricks partner since 2016. We've been awarded the Velocity Partner of the Year, and recently we won the Data and AI Governance Partner of the Year for 2024. Today's webinar is going to showcase quick, actionable tips to optimize your Databricks environment. So without further ado, let me introduce you to Michael Halleck. Hi, Mike.
Hi, Susie. How are you?
Very good. What do we got in store today?
Well, today, I think as you already teed up, I'm pretty excited we get to share with you all some of our favorite strategies to optimize your Databricks environment and associated cloud providers environment. And these strategies are powered by our Lakehouse Optimizer. We're going to be able to investigate how we can both help you improve your cost as well as performance together. So today we're going to talk about, again, 5 key areas, and in order, we're going to start discussing how you can appropriately be mapping your organization for chargebacks and attribution. We'll also discuss balancing cloud and Databricks costs as well as how to achieve the best possible discounts. Then we're going to dig into eliminating waste in all-purpose clusters, one of those areas that has a lot of low-hanging fruit and a lot of opportunity. We'll finalize things by looking at how to harmonize job orchestration and some more tips on choosing between serverless and classic compute. So to that end, we might as well jump in and start sharing our screen here. Now that I'm sharing my screen, we've landed on the overview page of Lakehouse Optimizer. This part of the interface is essentially the highest level part of an overview that's designed to make sure that executives, managers, folks in FinOps or the Center of Excellence have a clear understanding of the overall health of the environment and trends from an overall perspective as it relates to spend and performance as well. Starting up here at the very top, we're going to go around the horn and start to showcase some of these capabilities while we begin to answer some of the questions about how to begin optimizing your environment. This first area up here in the Lakehouse Spend section is going to harmonize the overall cost in Databricks as well as cloud and provide you an aggregated total. I happen to be demoing out of an Azure Databricks environment, so you might see some specific mentions of Azure Databricks in this demonstration. That said, the same corollary exists in AWS as well. The reason why this is very important to understand is because depending on your Databricks SKUs that you are leveraging and your overall architecture that you've chosen to use within Databricks, you might have a different perspective and a spread between your cloud cost and Databricks cost, and each one of the decisions that you make might start to shuffle the bill in one direction or the other. And so by having a clear perspective of both, you can make the most appropriate architecture and configuration decisions by keeping in mind exactly what the ramifications are going to be for each. And this is the kind of granularity that will also be pushing down to much lower level details and interactions within Databricks. And we'll show some examples of that while we dig in here as well, so you can start to expect to see this information more consistently. Over here on the tagging area, this is where we start to leverage chargebacks for attribution and getting a more clear perspective of how the organization can be mapped. Essentially, there are a number of different ways that you can leverage the native Databricks tagging functionality. Right now, I'm showcasing how we have some business units that are tagged. You can see untagged areas, which will represent sections that have no tags. We like to call these orphans. These orphaned areas, of course, need to have additional tags so you can more granularly track and provide that level of attribution. So it'll call that out here. You can drill into these underlying areas as well and see the workloads that compose these, and we'll show you some examples of that here in just a little bit. I also see in the field a lot of scenarios where organizations are tracking more than just business units. You can look at overall creators, owners, projects, workspaces. Essentially, the sky is the limit for any of the kind of abstractions that you want to be mapping and tracking. You can essentially set up Databricks tags. Lakehouse Optimizer will read those in and provide some deeper analytics and recommendations based on how you choose to segment your environment. So there's a lot of flexibility built into that as well. You can see the overall trend again and a similar perspective of the spread between the cloud costs as well as the Databricks percentage of that as well. Before we drill into one of these individual tags for one of these business units to show some more optimization opportunities in there, I'm going to briefly touch on what this optimization health section does. You'll see here that it represents that we have 92% healthy spend, 8% unhealthy. What's happening behind the scenes in Lakehouse Optimizer is we have an intelligent recommendations engine, which is running in the background, essentially in near real time, introspecting your Databricks environment. And it's going to grab and provide notifications and alerts whenever there's an anti-pattern that it detects that will cause an opportunity for you to act in order to perform some kind of optimization activity. So whenever we have a scenario where there is room for improvement or an optimization that is available for you to perform, the amount of spend that's related to those optimizations is going to be characterized in that unhealthy spend category. So that will give you a sense of the size of the prize and really the level of importance of engaging in and providing the optimization efforts that are going to be prescribed by Lakehouse Optimizer. I'm going to go ahead and drill into the solutions delivery category here in just a moment. But first, we're going to go ahead over to the workspaces area. And one of the things we wanted to be able to share was essentially how you can balance your overall cloud and Databricks costs and discounts. So within this workspace area, one of the things we can do is we can set budgets and overall commitment levels. Right now, I have a number of different Azure subscriptions. Again, in AWS, that would be related to your overall AWS accounts. Within here, I can also drill into individual subscriptions. So for now, we're going to go take a look at our Blueprint data engine, for example. And on each one of these individual ones, you can specify budgets and commitment levels, and it will give you a better perspective on how well you are tracking against those commitments and whether or not it makes sense to approach a more sophisticated commitment level. The reason why commitments matter, and I'm just going to hop over outside of LHO here for just a moment, just to explain how commitments and discounts work within Azure Databricks in particular. Right now, I just went over to the Azure Databricks pricing area. Again, similarities exist within AWS as well. They're very proportional and relatable. If you take a look at the pre-purchase plan opportunities here, you can see essentially a table of the value of Databricks commit units with the overall price that is included with the discount and the discount amount here on the far right-hand side. This is for a 1-year pre-purchase. They also have 3-year pre-purchase plans as well. What I want to emphasize is if you feel confident and comfortable with the volume of Databricks consumption that you have today, a commitment is essentially a no-brainer because you can get that discount amount available to you just by simply acting on that. What we oftentimes find, however, is that organizations are a little bit concerned with their variability in pricing because they don't necessarily understand how Databricks works and what the overall room there is for optimization. And so by pairing together, like what we were looking at before, the organizational health area, following all of those recommendations for optimization, you can find an appropriate baseline, establish what your commitment should look like, and then immediately grab the most appropriate discount for that level. Right now, you can see I have a Databricks commitment level set here at $12,000 a year. This is a fairly small environment. And you can see here I had 1 month that happened to be over budget. That was flagged here in this orange bar here. The other sections are still showing that they are within budget, so that's great. And you can also get a sense from a reference line perspective whether or not my commitment actually makes sense. I have a few months that are lower, some months that are higher. You can see that trend of usage is moving up to the right a little bit. Generally expected as an organization continues to adopt Databricks that we will be consuming more, but this will give you the confidence to understand exactly how your usage overlays with that discount amount. In this case, if we take a look at, say, the past 12 months of my overall usage, and I just expand this to more subscriptions like what we were looking at here just a moment ago, you can see that previous table we were looking at before on the Azure Databricks website. It shows we can easily get about a 4% discount just by going with the lowest level of commitment here. So again, kind of a no-brainer, assuming that you have the confidence that you need with the predictability that Lakehouse Optimizer can help you provide with your overall Databricks environment. Another area that I'm going to show here is this workspace stats section. I'm not going to read through all of these items, but essentially suffice it to say, we look at all of the different Databricks SKUs and all of the different interactions happening within the platform. We'll provide some overall reporting as it relates to relative usage within each one of these sections. You can see here we have things like job clusters. We even have reporting as it relates to serverless compute, and we'll talk about that a little bit towards the end of this demonstration as well. But you can see most of my usage here is generally related to all-purpose compute. That's something that we typically see pretty frequently. All-purpose compute is something that the data practitioners are going to be leveraging very frequently for all of the flexibility that they want to leverage Databricks for as they're going about using essentially a variety of different interactive workloads. And so by that, of course, we mean that if you are a practitioner that is actively working within Databricks, you're probably going to be writing and executing code that occurs on an all-purpose cluster. Of course, once that code reaches a certain level of maturity, we highly recommend moving things over to job clusters. And we can talk a little bit about what the overall cost savings and what the implications of that looks like here as well. What I'm going to do now, though, is we're going to go ahead and drill into the all-purpose compute section. So kind of taking it a lower level underneath this workspaces view down into workloads. And from here, we're going to start to discuss some more of the best practices that we typically find essentially on day one of deploying Lakehouse Optimizer within an organization's environment, starting with all-purpose clusters. So I'm going to hop over into the workload section here, and we're just going to jump over to the all-purpose clusters area. And I'll just make sure that we're looking at the correct part of the environment. Let's head back over to our Blueprint data engine, and I'm just going to open up my Lakehouse Monitor demo site here for just a moment. And what I'm actually going to go ahead and pick on is one of my colleagues. His name is Alex. He actually does a lot of really great work. He's one of our data scientists here at Blueprint. He has a couple of clusters, and we're going to drill into some of the insights that you can see here. But before looking at one of those particular areas, the biggest thing that we want to look at for all-purpose clusters, just to start, is the notion of the amount of idle time that's set up. So when it comes to idle time, again, when a Databricks cluster is up and running, you're essentially paying for that total amount of time, whether or not you're actually executing code or not. And so you'll see that Lakehouse Optimizer is going to report the overall active as well as the idle time available. We also have the cost information that's built in here as well, where we can see overall cost details from VMs, disk, network from the cloud provider side of things, as well as cloud costs aggregated in total, and then the Databricks DBU charges as well. So continuing to push that level of information down to significantly lower levels of granularity, we want to make sure that you can keep in your mind a complete balance of what sort of cost picture you're looking at, and then how that relates to performance, so that you can essentially optimize your environment for either one of those two essentially guiding North Stars, if you will, and hopefully find the best balance for what your organization needs as it relates to the kind of value that you can get out of Databricks. So again, we want to make sure that we turn down idle time as much as possible. That's essentially, if you imagine just a car idling in the driveway, it's just going to be burning gas and it's not going to be very efficient. Databricks has the opportunity for you to set up policies that can automatically terminate clusters. And so we'll detect what those policies look like. Over here, I haven't shown you yet, but at the very end, we'll take a quick peek at the incidents area, which will show some of the different incidents that are flagged, again, based off of the recommendations engine. Areas, for instance, that show when you have a policy that hasn't been set properly, or a policy that has set above too much of a threshold, or just overall increases in idle time versus what your expectation looks like. That's probably the first place that I would look, and that gives you a really great picture to understand. Essentially, for example, if I start drilling into Alex's cluster here, over this date range, it looks like he used about $20 worth of all-purpose compute. 51% of that was idle. So that's a great opportunity to save and to find some improvements. And again, we can drill in to understand what the usage and behavior really looks like with these all-purpose clusters and do some more sophisticated analysis beyond just making sure that things are active and idle. We oftentimes get the question of how active is this cluster actually, and is there some more opportunity to reorchestrate these workloads here? So one of the things that we'll want to look at is just drilling into the autoscaling timelines. So if you have autoscaling enabled, autoscaling is a great feature from Databricks to help you when you have a lot of variability in terms of the kind of compute that's going to be required to make your workload run well. That said, there's also room for improvement to make sure that you are using autoscaling appropriately, and like anything else, with a more clear and fundamental understanding on how these things work and what it really means in your environment, you can make better informed decisions, and Lakehouse Optimizer will make that a lot easier for you. So if I drill into the autoscaling timeline here, you can see all of these different segments. So the first one that I have will show that we just have one worker that's been established, and then it terminated. The cluster was stopped for a certain period of time. You can see it turn back on again. So you can kind of get an overall sense on the cadence of work as he's continuing to develop on his cluster, And before the timeout period hits, he's continuing to execute more and more workloads that actually run on here. You can also see we have some very short auto-scaling segments. And one of the interesting things about auto-scaling is it usually takes a couple of minutes for Databricks to provision new resources. It's just a matter of essentially the cloud provider that you are on taking a few minutes to spin up a new VM, provision all of the libraries that are needed, and then to start apportioning data, and then it can become part of the fold as it relates to auto-scaling. What I typically see when I start to show some very small, tiny auto-scaling segments, I almost can't really hover over it. You can see this one here. This one only lasted for about 20 seconds. One of the things that we oftentimes find is a mismanagement as it relates to leveraging spot versus on-demand instances. And here's a scenario where LHO actually picked up on using a spot instance when it actually lost that instance. And although spot instances can be generally less expensive than on-demand, that lack of stability can also extend the timeline for the job to run, because it has to grab another machine, it has to start rebuilding that part of the process that was lost, and then it can continue to execute. So whenever I see these really short auto-scaling segments, that's usually a great indication that the user should probably start to avoid spot instances if I start to see a lot of those, and leverage on demand, even though those are going to run at a higher consumption rate. Those on-demand instances are going to be more reliable. You'll have a shorter overall length of execution. And then again, that's likely going to net not only a great performance and a reduction in latency for your jobs to complete, but then commensurately, you'll also gain in savings by having the job execute faster, even if it's running at a slightly higher rate. So it's always a good idea to look at these short auto-scaling segments, and LHO obviously makes that very easy for you as well. You can see where we recovered again right next to that. We went back up to 4 worker nodes, so auto-scaling seems to be working well. A couple of other small sort of jittery areas, which it looks like we're also, again, losing some auto-scaling segments as well. And then we go back down to a single worker node. Another thing that we notice too, and you'll kind of see this with some of the smaller segments, is oftentimes auto-scaling can have a little bit of jitter behavior. And when it relates to jitter, what will actually occur is by the time the few minutes of auto-scaling provisioning actually occurs, it might already move past the need for those resources to be available. So it might grab them really quick and then release them again. And then again, that's another great opportunity to start to dig in a little bit deeper to what is actually occurring within any one of those jobs or notebooks that's being executed, and then find a better opportunity to appropriately size the resources that are being used for that job, and maybe even make some code optimization opportunities as well. That obviously gets a little bit deeper. But again, these are some of those early indicators that we can use to get a better perspective on how, for instance, the auto-scaling parameter within Databricks is being leveraged. And then, of course, improve the level of management of that to improve cost and performance again. So you're going to start to see that as a theme going forward while we continue to have this conversation a little bit. Another question we oftentimes get is, well, that's great, but can you tell me what's actually happening on this cluster? And can you give me better insights into whether or not I can consolidate clusters or do some more load balancing? So you can drill in. You can see when I clicked into this little menu icon, we have the opportunity to look at various jobs, notebooks. We can also drill directly into workloads within Databricks as well, which is a very convenient method of using LHO, having it available on one of your monitors in front of you so that practitioners can essentially be making any sort of improvements or changes within Databricks as Lakehouse Optimizer is acting like a co-pilot to help inform what those decisions really should look like. Obviously, we were just looking at the auto-scaling timeline here, but what we're going to do is we're going to go ahead and take a look at jobs that are running. Let's go ahead and drill in here. And actually what I really meant to do is I meant to go take a look at notebooks. So it's actually a good pattern that you didn't see anything in there. Jobs running on all-purpose clusters, spoiler alert, are a lot more expensive than any kind of job that runs on a job cluster. And so we always recommend that you take a look at those. LHO will detect those. It'll also provide alerts and notifications based on any one of those recommendations, which you can subscribe to. So as much as we think that our interface is great and you probably would like to spend a lot of time in here, there's a lot of individuals that probably can't spend a ton of time in LHO or they're busy doing other things. And so this kind of helps them understand when they should tune in for some more action rather than having to sit here and monitor the application itself. What you'll notice here is in this view, we have a couple of notebooks that ran. You can see the overall fully qualified name of each one of these. total number of runs for each one as well. You can see the amount of cluster memory that was being used, cluster CPU. Kind of the interesting thing you might notice is that some of these numbers are also fairly light. Less than 30% cluster CPU is usually a good indication that this job is over provisioned, and it's also a great opportunity to do a couple of things. You could either turn down the size of the instances that the job is actually running on, or you can also consider reorchestrating the usage pattern for this particular user on his cluster to leverage a shared cluster. So you have some cost that's already getting wrapped up into the rest of the organization as opposed to having just an individual cost center that exists here. I can also drill in directly to each one of these individual notebooks. And we can see, for instance, again, we had a couple of notebook runs that existed there. You'll also notice this very similar badge for number of incidents. That's going to give us some information about the overall health and performance of this particular run. And so drilling in here now, this is where we get to a lot more deeper details to really help validate and provide a better perspective on making some great improvements. So what this is going to show is the number of worker nodes, the driver node specifications, the overall instance rates. It'll also break down that instance rate to see again where it's going. So similar theme, pairing both the single pane of glass for cloud cost as well as Databricks cost together. We can quickly see what the VM cost looks like, as well as the standard and Photon enabled rates for that VM. You'll notice Photon acceleration was enabled for this job, and so that's why we have that aggregated instance rate that you see. We'll also start to pick up some other issues. So again, that incidents and recommendations engine is running in near real time behind the scenes all the time, and it's going to grab all of this information, turn it into something that's human digestible with some very clear and prescriptive actions. So it takes away a lot of the mystery for what is available to be improved within Databricks, and then simply allows you to jump back into the platform, make the simple configuration changes that you might need to make, and then you can verify the results by jumping back into LHO. What this picked up is it found a few different scenarios that we described for over-provisioning. It found it on both the cluster CPU as well as cluster memory, and then also on the driver CPU and driver memory. And again, what we want to make sure that we do with these recommendations is equip the user with a clear understanding of why we made the recommendation. The last thing we want to have you do is essentially blindly follow these recommendations and then wonder why they didn't avail the kind of results that you were looking for. Of course, you get to bring in your own level of business context for what these workloads are doing, what they're for, and then by pairing it with all of the rich telemetry and insights that come out of LHO, that allows you to make the most informed and appropriate decision for the business, so that you can have the right amount of, again, balance for cost and performance. You'll notice here, again, we're using a very small amount of the overall resources that are provisioned. And so what LHO is going to do is it's going to find the opportunity to improve the efficiency of the configuration. So in this case, it decided that you should scale the cluster into 2 worker nodes instead of the 4 that was available, even though it was running at that high level of utilization that we saw in that auto-scaling timeline. Again, it still isn't using all of the resources that was provisioned, and so it's a great opportunity to narrow that gap a little bit. It also will identify specific VM instance types that you should change the driver node to, as well as the worker nodes. And we'll also show you what the overall rate adjustments look like for each. And then again, the corresponding information about amount of memory, number of cores, etc. Just by making these simple recommendations, which you can do in just a few moments within Databricks and just a few clicks, we can easily, at least in this particular case, save 50 to 75% by dropping the number of worker nodes, going to a less expensive instance rate. And by doing this, we also can expect to not have any reduction in performance because we're barely using the overall size of the environment that this particular notebook has been provisioned on anyway. So it's a fantastic win-win type scenario where you have essentially a lot more efficiency and really no compromises for it. LHO is going to pick out and help you identify these opportunities and make it really easy so you don't have to hunt and peck for them. And that will allow you to very proactively improve the health of your environment rather than just wonder why your bill was what it was or why a job was struggling or having issues. So it'll really help clarify that and then again give you those prescriptive steps that you need to be able to make improvements. One of the next things we wanted to take a look at was how to harmonize our job orchestration. And that's kind of a complicated way of saying that there can oftentimes be just a much more efficient way to have jobs laid out and how to make sure that they are working well together. One of the areas that we have some really great insights in is as it relates to pools. So pools are a very interesting component within Databricks. Essentially, what it allows you to do is to have kind of a series of machines that are available so that you have faster startup times for your jobs. Again, the challenge, though, is you can potentially have some lack of efficiencies within that. And those lack of efficiencies can materialize themselves like idle time or something like that. If you ever go to the airport and you say, are going to go to ground transportation and you're going to wait for an Uber or a Lyft or something like that, you typically don't want to wait very long. And there's kind of a balancing act of having too many cars that are available, sitting there idle, burning the meter, getting paid to not drive anybody. And then you also have a scenario where if you have sort of the right amount, then everybody's really happy and nobody's actually waiting. You don't want to go the other way and have too few vehicles and then have people wait for too long for resources to spin up or things like that. Pools are a really great mechanism that are supported by Databricks. The challenge is there's just not a lot of insights that are available to be able to leverage them to their fullest. And LHO, again, will make that a lot easier for you. So what I've done is I found a particular pool that has some activity in it. Each one of these colored segments is going to be related to a specific job that is running within this pool of resources. We can also see the number of VMs that are set as the minimum, maximum, as well as the timeout policy. So essentially, once the pool gets active, how long it will take for the pool to remain available for new workloads to jump in before it starts to turn additional VMs off. Again, if it turns the VMs off, then you don't have the benefit of the pool up and running for fast startup times, but then you also want to make sure that you're balancing out the waste as well. So you can actually see here, these jobs, as they are stacked, they are not only beginning to execute, and more jobs are coming in and leveraging components of that pool. You can also see how additional VMs have been allocated for autoscaling. So this particular job happens to be called the Train Weather Model for Region 1. You can see now we've added a couple of additional VMs. We have 3 that are running in total, so we've had some autoscaling that occurs. And you can essentially follow the trajectory of the job and all of the competing jobs that are running and starting to grab additional resources. What's interesting here is you can see another essentially small autoscaling segment here. And the reason why this is so noteworthy, this one happened to last for only a few seconds. That's probably because we had a spot instance that ended up getting lost. Somebody outbid for that spot instance, and so it's now no longer available. What can actually happen though is, again, either there was a spot instance that was being lost and we can drill into that, or this just happened to be a little bit of jitter where we had autoscaling that occurred, but it ended up not necessarily being needed by that job immediately after, and so it ended up downsizing. What ends up happening, and you can see in this darker shaded area, this essentially is the idle time that has been generated. You'll notice the overall length of that idle time is essentially the length of that timeout policy, and so you can see, in this case, 12 minutes later, you can start to see it start to taper down. But then we have this great chasm in the middle where we have an opportunity to start dragging those additional workloads forward. I have 3 more here. I have, it looks like, additional weather model training that needs to occur. And these opportunities to execute these jobs become a lot more visible in this view, where you can see how I literally have idle VMs that are sitting here. And so by looking at a view like this, it can give you a very clear indication on how I should start to, and which jobs are sitting there waiting for me to start to drag forward and orchestrate better. Or if I'm comfortable with it, I can also turn down the overall timeout policy as it relates to that as well. My recommendation for this, of course, would be to say, you have VMs that are sitting there waiting. Let's go ahead and get those extra jobs to execute faster. Again, that will drag down the SLA. It'll ensure that you have more rapid data availability for each one of these jobs. And everybody is more satisfied at the end of the day with faster and higher performance, and doing that at a lower cost perspective as well. What we can also do with this is we can drill into any one of these workloads. So I'm just going to hop into this first one here. And then once it pulls up that workload, we can start to introspect this job and again, start to look for some more room for improvement here as well. Again, something that's worth noting is these same strategies for orchestration, they also work for serverless workloads as well. And we'll spend a little bit of time talking about serverless when we start to wrap up this conversation here towards the end. Similarly, like we looked at before in all-purpose clusters, this is something that's running in a job cluster. Here we actually can show what the overall run cost looks like. It looks like we have 6 incidents that have occurred. We can also see the amount of data that's being processed, showing data in, data out if relevant, if it's writing to anything external. Also the amount of shuffle that's occurring between the various nodes that are running. Oftentimes we can see some very large amounts of shuffle can demonstrate some poor efficiencies in how the parallel computing aspects are working, and so that can lead to some additional recommendations that LHO can highlight. The other thing that's really nice as well is we'll take a look at the Spark tasks. So we'll show the number of successful and failed tasks as well as total. If there are any failed Spark tasks, rather than dig through the Spark UI to try to look for them and wait for what can oftentimes be hours for a very long-running job, even just for the Spark UI to render, which again, it also gets purged if you happen to follow the best practice of turning the infrastructure off in a more timely fashion. You don't have those insights available. LHO is going to cache this information and make it available to you at a later date so that when you're ready to invoke that optimization opportunity, you can still go back and see exactly what occurred and make those improvements. Something else that's also probably worth mentioning just as a brief aside from an architecture perspective, LHO is deployed within your Azure subscription or AWS account of choice, and it runs entirely self-enclosed within your environment. So there's no data that actually gets pulled out from Blueprint to be able to observe anything that's happening within your environment. So from a privacy perspective, everything is totally safe and secure. And then all of the data is also made available to you. So from any one of these richer telemetry details, if you want to provide your own analysis, or if you want to do any sort of integration into other sorts of reporting, we have Databricks notebooks that are available to be able to ingest this back into Databricks so that you can start to leverage this information in, maybe a more tailored to you forecast, or if you want to be able to see similar insights delivered into your BI tool of choice further downstream. All of that's at your disposal. Just wanted to let you know that that data was fully contained within your individual customer's environment. What I'm also going to take a look at here, again, is kind of going back into incidents. So we saw a similar view here before. In this scenario, we also have auto-scaling that's occurring. We have a specific instance rate that's related to this type. We can see we have another scenario where we have a lot of over-provisioning that's been identified. And so the recommendation here is also scaling this one down to 2 worker nodes, and also scaling the driver node down to specific instance types. Something that I also recommend, and LHO will also call out, I sort of skipped over it here, is it will say, go ahead and apply one optimization at a time, make those changes conservatively, then rerun them again. Again, LHO is going to essentially near real time pick these up. So within moments after one of these jobs executes, it'll be available in LHO again with all of the telemetry processed. And you can see how effective that optimization improvement was. You can literally see the most up-to-date cost and performance metrics for any one of those runs. So you don't have to wait a day or so later to be able to see what those results actually look like. You can just allow LHO to essentially have your back while you're making those improvements, and it'll continue to validate and help essentially train on that behavior to provide more enriched recommendations as you continue further down. The other thing that I'll also note is when it comes to some of the details that you can see here, we'll show if the execution of the job was actually successful or not. We'll also help you flag whether or not the telemetry was fully analyzed. If there's a job that is actively running, you can see essentially the telemetry details for that job while it runs. You can configure how often that gets refreshed. We have some really great scenarios with long-running jobs or like streaming jobs, which essentially never really stop, where you can continue to essentially on demand grab the most up-to-date telemetry and see how that job's health is performing before actually waiting for the job to conclude. That way, if you have a scenario like if it's trending towards out of memory, or if it's about to run into some issues that you might have seen historically, you don't have to wait for it to go all the way towards the end and maybe hit a failure. You can actually see some kind of early warnings as well. And again, those will be built into the recommendations and incidents as LHO is continuing to monitor the job and essentially the entire environment and all of the interactions that are happening within the platform as well. Awesome. What we also want to do is have a little bit of a discussion for serverless and classic compute. So what I'm going to do here is I'm going to back out Let's go over to our workloads area. We have a full serverless section. And what happens here is where we have serverless activity. I think I need to go to a different section. Here we go. I've got a couple of serverless workloads that are being run. This is actually kind of an interesting and cool use case, and probably, spoiler alert, going to be the topic of one of our upcoming webinars that you'll definitely want to tune into. Our managing director of innovation and product by the name of Gary Nakanalua, he's been experimenting with generating project stories by pointing a large language model that he built in Databricks at our essentially internal database for all of our project documentation, and creating interesting project stories so that we can evangelize all of the great work that we're doing here at Blueprint. And it looks like his most recent run like that, he ran that in a serverless environment and only cost him less than $5 to generate, which seems like a pretty good deal. So what we have here is we'll be able to demonstrate the cost as well as the duration information, and also help you identify the number of runs that are actually being analyzed. Looks like you ran it a bunch of times, and even just the individual runs are, you can see the specific cost and specific duration information as it relates to each one of these. The reason why that's so important is as you start to make the comparison between serverless and classic workloads, cost and performance is really what we want to uncover as our bottom line. And so when you shift a workload from one to the other, you'll be able to see not only if you have different instance types or you have different configurations, you make updates to your code, you'll be able to see how cost changes and how duration gets adjusted for that, so that you can find what the most appropriate balance is for the size of the resource that you're running and whether or not that's going to meet the SLA that you're looking for. All of these thresholds are configurable as well. And so if you have costs that balloon out of control, you can set those based off of the specific value or based off of a percentage. And that will allow you to make sure that those costs are being reined in and that they don't just happen without your input or observation. The other thing that's probably worth mentioning as it relates to serverless is, depending on the kind of workload, some jobs might run really well as serverless. Some actually might be great candidates for classic compute as well. And LHOs can help you make that decision overall and provide you more validation on what's the most appropriate approach. Oftentimes you'll find that short-lived or essentially spiky jobs, like we kind of took a look at previously, I'll actually jump over to where I have some more content. Short-lived and spiky jobs will oftentimes be really great candidates for serverless. We mentioned before, when you have jobs that are running for less than 5 minutes, for example, instead of waiting for Databricks to spin up and be provisioned, like you can see here, overall duration of jobs, I can actually go ahead and sort by longest job run duration, just to get a sense of some of the content that we have here and find some of the short ones. Here's a great job, daily warehouse inventory metrics. This would be a perfect example on something that we should probably consider orchestrating over with serverless. It's more than just your jobs though, because you can also do serverless compute for individual tasks within an individual job. And so you can blend serverless and classic together and essentially pick the best of both worlds and find the right balance to make sure that you're not spending too much time managing all of this infrastructure, and then of course letting Databricks do some of that work for you. Spiky jobs are also beneficial, where serverless will have your back from an auto-scaling perspective. And so if there's more unpredictability there, that can also be a great opportunity. What we can also show when we drill into any one of these individual jobs, actually go back out and we find one that I ran more recently. Let's take a look at going to most expensive job runs. And I'm going to take a look at this Alpha Supply Chain Monitor job. And the reason I like to drill into this one here, make sure I can get some more job runs. This one I haven't run for a little bit of time. The interesting thing about this job is we have a bunch of tasks that are actually running within each one of these. And so when we drill into the tasks view here, like we said before, I actually found a scenario where we were running a job in an all-purpose cluster. And I think I might have mentioned that, spoiler alert, that's not the best practice. And we can actually jump out here and show what how significant that can actually look like. We can see for each one of these tasks the amount of data that's being processed, the overall duration. And when we take a look at the duration details, we can see things like setup time here. This particular task that was part of this job overall took 3.5 minutes to set up. It took literally about half of that to execute for a total of about 5 minutes. So your strategy in saving this overall setup time could be potentially leveraging serverless here, or it could be essentially running this within a pool, assuming that the pool is actually active. And so you can start to imagine for one of these scenarios where we have 18 tasks, and most of these are fairly short. I've got one of them that ran a little longer. You can see this one here again, similar amount of startup time, some more execution. It's a little bit healthier. And then we have a bunch of these that are actually running at very short segments and very short intervals. Anytime that we have one of these smaller sections, especially, like I'll jump into one of these here again, 4 minutes of setup time, 42 seconds of execution. The amount of savings from a time and efficiency perspective essentially is compounded by switching to serverless in this example, or again, leveraging pools if you have the appetite to manage them. And we took a look at a little bit of an example of that here in just a moment ago. The other thing too, again, that LHO will allow you to do is, of course, do some A/B testing between the two so you can see how efficient each one of them is and make the most informed decision based on your architecture and what you need to ensure that your SLAs are being met. I've got another couple of cool examples now that I've gone through some of those suggestions. I've got a few minutes left, so what I'm actually going to do is let's go ahead and jump back out to workloads. And I need to go into my Blueprint Labs area and then in Blueprint Demos. And I'm going to drill into this appropriately named classic job. This is kind of an interesting one here because what I want to be able to show is even more deeper levels of telemetry data that LHO is collecting. We have all of these really incredible recommendations that come out of the platform, but there's always something more and something new that an organization is using Databricks for that might not necessarily have a ton of analysis built in. And so what LHO will allow you to do is not only to leverage the prescriptive recommendations to be able to validate some of the specific details that are being provided for why we've made those recommendations, but you can also roll your own recommendations. So I'm going to show you a couple of examples on some areas that you can drill into this even deeper as well. In this example, I'm also going to show how we have some more additional details. We took a look at an auto-scaling timeline before. I'm going to take a look at the cluster instance activity histogram, as we like to describe it. So you can see I have a specific cluster instance that's being run here. And we're going to drill into this. So what this is now showing is essentially all of the underlying details for how this job was actually run and how various system resources were being utilized. So here we can see that we have a few different perspectives. Right now I'm looking at multiple workers all at once. You can see the driver here as well as the executors. And you can see from a timeline perspective how it's actually leveraging more of the driver. Right now I'm looking at CPU system load. We have other operating system level metrics that are included here as well. So CPU system and process load, as well as the availability of memory as well. And you can also see how these additional executors are running and get a better sense on how well parallelized those are, if they're actually being utilized well or not. One of my favorite features here is this ability to turn on the merge tabs feature, which will essentially take all of those executors, collapse them into one, and you can actually see here, this is actually pretty neat. These are all being pretty well utilized, essentially in parallel. That said, early on, they're not being utilized all that well. At the beginning of this job, it looks like we're running at maybe about a high of the low 20s in percentage. Moving forward, it moves into sort of the mid 20s, maybe a smaller volume of data was partitioned to executor number 0 there. Going back up to the driver, we can see it's not being super well utilized either, although at the beginning when it was dishing out instructions to all the executors, it was a little bit more warm. The driver's not being utilized fairly much at all towards the end. That just happens to be the nature of this job, which is generally okay. This also helps represent a deeper perspective of what the potential ramifications could be of any one of those optimization recommendations. What I didn't show here, we'll jump back and take a look at it here in a moment, is the recommendation I would assume is going to help us with identifying that the driver was over provisioned. Again, it's not using too much of the driver during this time. The executors are doing okay, but you can also see there's still some room for improvement here. They're only using about 50% when they're all working as, I guess, as much towards the peak as possible. You can see, though, that this is a great job for parallel processing. They're mostly consistent overlay. What we'll oftentimes find, and this is one of the most heartbreaking scenarios, is when somebody has one driver running a ton of executors because they want to have a job run really fast. And we hear folks ask us, hey, why, when I upsize the volume of executors, why is it not performing my job any faster? And what we'll oftentimes find is that most of the executors are idle. and or maybe just the driver is being utilized. Maybe there's the type of code that's being run, like just something of a very naive Python notebook that's being executed, and it doesn't have a provision for parallel processing, and you have a bunch of idle executors. And so we'll find scenarios like that, which will help us identify if we need to start digging into the code a little bit deeper or making some deeper changes, just to make sure that there is, a more efficient processing happening there. Or again, just reverting back to some simple configuration changes here. In this case, it looks like we can probably get by with fewer executors to be able to get the job done. That's going to allow us to get this to occur in likely a similar amount of execution time with a reduction in overall spend as well. So if we go back out here and start to take a look at some of those incidents, apologize, I skipped over those. These incidents, again, you'll actually notice kind of what we saw. Over provisioning. So that was just a little bit of a look under the hood on how our algorithms are picking up on these patterns, detecting those issues, and then making some recommendations as a result. Again, this will summarize that information. You can look at it more in simple text-based readout, so you can make a direct change in your environment. But then you also have the visual representation as well, which can be very beneficial if you have some interesting anomalies or just really want to know exactly what's going to happen as you drill into this a little bit further. Something else I actually forgot to mention, I'll go back over to one of these histogram views here. And let's go ahead and merge charts again. This run was a little bit different, actually. Let's go back to the one that we looked at before. Back to the histogram. I think this is the one that we looked at. Something that's also worth noting is early on in this job, again, we have a couple of strategies. We talked about the over-provisioning scenario where you can just simply go into Databricks and change the instance type and make that really easy, or reduce the number of executors. What you can also consider is the different sections of the code that's actually being written. Oftentimes we'll find a scenario where we have these flat spots where we'll find asynchronous callouts that are happening and we're essentially waiting for responses. We'll see this very often when we have additional systems that are out there in the wild that are, again, being paired with Databricks. There's a couple of opportunities for potentially vendor consolidation when we see those sorts of patterns happen a lot, where essentially Databricks will go idle while it waits for another slower and less responsive system. Whenever we find those scenarios, we like to track that back, and then typically it becomes a great opportunity to find more improvement by consolidating those systems back on the Databricks. But even within Databricks, this is a great opportunity to take a look at your code a little bit more intently, see what's actually being executed between the start and this particular time period. And oftentimes we find that there are some very clear and logical breaks of the kind of tasks that are happening, where you can essentially break this into subtasks within this particular job, run them in series, and specify more optimal infrastructure for the first half of the job, where it doesn't necessarily need all of the resources that are being used. And then for the second half of the job, where it starts to ramp up the level of performance that is being leveraged, then you can have right size for that as well. So it's just another great opportunity to start to think about some more granular orchestration opportunities here as well. Got a little bit more time, so one of the last things I'm going to show is, let's just jump over to the incidents area. I know I teased about that here a moment ago. And what I'm also going to look at is just kind of a quick preview of all of the different incident types here. We have a bunch of them. There's about 40 that are listed in the app, and we're continuing to add more on a regular basis. So we've got coverage over workflows, DLTs, notebooks, all-purpose clusters, pools. What I'm actually going to look at, again, one of those really easy optimizations. And if there's one thing that you should remember today coming out of this, just an easy optimization that can save you a pile of money, is take a look at jobs that are running with all-purpose clusters. And if you're having trouble finding those, LHO can make that really easy. Just a simple selection there. That'll bring back the specific incidents for that scenario. Let's also expand our date range a little bit too. Looks like we've since cleaned that up. But let me also make sure that I'm looking at the right area here. Okay, great. So what we're going to take a look at is, you can see a bunch of these different job runs. One of the ones that I'm actually going to pick on here is this Alpha Supply Chain Monitor. I think we looked at that one again previously. But the reason why I want to dig into this one here is, let's just go ahead and open this workload. And you can see again all of the underlying details for this particular job. This is one where we showed all-purpose clusters, and so that was a little bit of backwards and forwards. You can identify those APCs that are being used in incidents and kind of direct yourself down to this. Or if you happen to be headhunting and you are working on that particular job by name, you can drill into that and you can make some improvements from there and kind of go back and forth. The reason why that's an anti-pattern and why I really want to bring that up is, let's just actually head back over to the Azure Databricks pricing page again. And for the total dollar amount, any one of those jobs, if you just take a quick peek at the amount of DBU consumption for each, all-purpose compute, the standard DBU rate is about 55 cents an hour. Job compute is 30 cents an hour. And that's in the premium tier. If you're leveraging a standard tier, it's 40 and 15 cents respectively. That essentially nets out from a simple configuration change just by moving those all-purpose cluster running jobs into job clusters. You can save 45 to 63%. Again, that's going to depend on your workspace configuration. So again, LHO will make it really easy to pick those out. It'll help you find not only the jobs that are running, but the individual tasks that are running on those all-purpose clusters. And all you have to do is just jump into Databricks with that handy button that we have available in the app. And that's going to allow you to simply make a couple of toggles to change that configuration. And then as you watch it run again, you'll be able to see that savings compound back in. So last thing I wanted to share, just kind of overall in summary, just some of those takeaways. Again, that was the one thing I really want you to remember, but kind of final notes is consider tagging your workloads. That's going to give you more granular management for the amount of value you can get from Databricks. Optimization is obviously going to give you the certainty that you need to unlock more discounts. And so as you continue to apply these recommendations and see that optimization health level increase, that's going to help you understand where you should be providing commitments, which can be very significant for discounts once you start to get into some of those larger tiers. Again, there's always room for improvement in all-purpose clusters. Take a look at jobs and take a look at idle time. Also consider taking advantage of the orchestration opportunities so you can get jobs done faster and boost efficiency. Everybody wins when you're able to leverage more appropriate orchestration. And last couple, consider, again, leveraging serverless compute where appropriate. But of course, like anything else, test it. See if it makes sense for your setup. LHO is going to make it easy for you to identify that and continue to manage it in an ongoing basis as well. So all that to say, I know there's a lot that I was able to share here, but hopefully you were able to see just how easy it is to unlock a ton of these improvements of LHO, how it brings all of that information to the forefront. It makes it really easy to parse through what you should be focusing on and when. And of course, harmonizing the efforts between the higher level personas from the Center of Excellence or executives in management down to the practitioners who are responsible for affecting those changes and extracting as much value out of the platform as possible.
Thank you, Michael, so much for presenting today. And thanks for all of you who have stayed on the call. We will definitely be getting this recording out to you after. Michael, before we conclude, anything else you'd like to add?
No, that's it. Appreciate you folks digging in and listening with me. And just one thing I did forget to mention is we just got off the line with a customer who was halfway through a trial. They simply within the first 2 weeks of them using the platform on their own, they were able to recognize $140,000 of savings using Lakehouse Optimizer. And those are the kind of savings that we want to make sure that you can take a part of as well, in addition to some great performance improvement opportunities. So I'm looking forward to connecting with you folks and finding some more ways that we can drive value in your Databricks environment.
Awesome. Thanks, Michael. And for those of you who are still on the call, why not give LHO a try for 30 days? It doesn't take long to see the value it'll deliver to your organization. And as Michael just said, $140,000 in annual savings in just 2 weeks that our customer just realized a couple weeks ago. We'd love to assist you with a deployment, although it's readily available for our Azure customers in the Azure Marketplace. You can also email me here on the screen, Susie@bpcs.com directly, and I can get you connected to our customer success team. Thank you again for joining today. If you guys have any questions about what you saw or perhaps the other services that we deliver, you can use that email as well, and I'll get you in touch with the right team. Have a great rest of your day, and thanks again for joining.